In this video, you will learn about linear functions. There are three different representations of functions. One is an equation that shows how the variables are related, like y equals 2x. Another is a table that identifies specific input and output values of that function. And the third is a graph. It gives a visual picture of what is happening across the function. As we just looked at, we have various different types of functions. We are going to compare and focus mainly on linear functions for right now. We have linear functions, a function whose graph is a line, a function with a constant rate of change, and a function that can be represented by a linear equation with two variables x and y. All other types of functions are non-linear. We looked at absolute value functions, radical functions, and quadratic functions already, but for now we are just going to specify linear or non-linear. A non-linear function is a function that does not have a constant rate of change, and a function whose graph is not a straight line. Based on the description on the previous slide, which of the following show linear functions or equations? The two that show a linear function are y equals 8x and y equals 6 times the quantity of x minus 1. The others do not show a linear relationship between x and y. When we are trying to determine if a relationship is linear or not, we need to ask ourselves the question, what do I need to do to get from the x variable to the y variable? In terms of what computation or calculation is being done to x to get y. Once I can determine that, then I can, if it's linear, write an equation to represent that relationship between x and y. If it's not linear, then we just say it is not linear. Let's take a look at some examples. What would I do to 1 to get to 5, 2 to get to 6, 3 to get to 7, 4 to get to 8? Is it the same every time? If so, it's linear. In this case, we are adding 4 to x to get y. Another way you can tell if it's linear is if the change from x to x is constant, so this goes up by 1 each time, and also the change between the y's is constant. If those two things are true, then it is linear. In the second example, we see that this increases by 1 each time, while this decreases by 2 each time. So we can say that that is linear. In our last example, this increases by 2 each time, this decreases by 8, and then increases by 8, and then increases by 24. So that is not linear because that is not the same change between the x and the y values. Now, if we try to write an equation to show that linear relationship, for the first one, we are adding 4 to each of the x values, so that's y equals x plus 4. So the x value plus 4 equals the y value. In the second example, we can use this information on the side here to help us figure out the equation. So if the y values increase or decrease by a certain value each time, in this case it's decreasing by 2 each time, that is actually going to be our coefficient of x, y negative 2 times the x value. Now that might not give us the direct answer to 7, so -2 times -2 isn't 7, it's +4. So then I might have to do something else to get to my final value of 7. -1 times -2 is 3, or is 2, excuse me. And then I need to, again, do something else to get to my final value of 5, which is adding 3. And so my equation is y equals -2 times x plus 3. Just to make sure it works, times -2, that's 0, and then plus 3 is 3. 1 times -2 is -2, and -2 plus 3 is 1. So using this information here on the side of the change of -2 for the y, as long as the x changes by 1 each time, that -2 comes down and appears as our coefficient. Now this nonlinear one is a little trickier. Oops. This one is y equals 2x squared. So it's the x value squared and then doubled. Now figuring that out is a little bit harder. If I found out that my y change was not linear, if I do it a second time, you can see this increases by 16 and then this increases by 16. If the first set of changes is all the same, like in these two, then it's linear. If the second set of changes is constant, then it's quadratic, or the power of 2 of x. So that's how I figured out that it's an x squared. And then if I square one of these, 2 squared is 4, and then what do I need to do to 4 to get to 8? Well, I need to double it. I could also add 4, but if I try that on another example, 4 squared is 16. 16 plus 4 doesn't equal 32, it's doubled. So that's where the times 2 comes from. Here's a couple other examples to look at. First, let's determine if it's linear or not. So on this example, the x's go up by 5, and then by 7, and then by 9. The y goes up by 1 each time. Oops. So since the x's are not the same but the y's are, that's nonlinear. And then obviously you can already see this is linear, but to show you why, this goes up by 3 each time. This goes up by 6, this goes up by 9. However, this goes up by 1, and then up by 2, and then up by 3. So since these are all different, these should also be different, but also we want to look at the ratio of them. 3 to 1, 6 to 2, 9 to 3, those are all the same. Okay, now when we are trying to come up with our equation, that first one's a little tricky. The square root of x minus 5 is a little hard to come up with. The second one, we actually want to look at not just the y change, because like I said in the last slide, the y change becomes your coefficient. But if they're all different, we need to then actually look at the ratio of y to x. So 1 over 3, or 1/3, becomes our coefficient. So once I take a third of each of these, what else do I need to do to get to my final y value? And then this one's the easiest one. I will subtract 2. 1/3 of x minus 2. So again, I got the 1/3 from 1 over 3. 2 over 6 is also 1/3, and 3 over 9 is also 1/3. Here's a challenge one for you to try. This one is nonlinear. If I look at the change, these ones are all the same, constant, up by 1 each time on the x, but you can see that the y's are very different. This would be the opposite of x cubed minus 1. That's a really tricky one. Again, just so you know, I would not expect you to be able to come up with that, just for a little fun challenge. Okay, we can also create a function from a word problem. In this example, Food Mart has a candy machine. Each time a customer inserts a quarter, 8 candies come out of the machine, and the machine holds 10 pounds of candy. Each pound contains about 200 individual candy. Define 2 variables and write an equation to represent the amount of candy in the machine for any number of quarters. So we have our variables here will be x and y. X being the number of quarters. Now this is a little bit different from how we wrote equations at the beginning of the year. I would have given you the amount of candy remaining and you would have found how many quarters, x. But for this one, we don't know the amount of candy remaining. So we have a variable for that, y. So this is where we get 2 different variables when we have 2 unknowns. So 8 candies per quarter, that's minus 8x, and then the 2,000 comes from 10 times 200. And then for the second part, it says the store owners don't want to let too much money come out of the machine, collect in the machine. So they take the money out when they think the machine has about $50 worth of quarters in it. However, they can't tell how much money is in it without opening it. So they judge by how many candies are left about what percentage full should the machine look when they take the money out. Take a few minutes to try to solve this problem. Pause the video for some extra time. First, we know that $50 times 4 quarters in a dollar is 200 quarters. So in our equation from above, we're going to plug in the 200 for x. So when I do that, I will have 400 candies remaining. That's my y value that I was solving for. Y equals 400 candies left. So the question says what percent full should it be? So there's 400 left out of the 2,000 pieces that were in there to begin with, which is about 20% full. Okay, and one final challenge for you. Your brother tells a secret. You see no harm in telling 2 friends. After the second passing of the secret, 4 people now know the secret. Your brother, you, and 2 friends. If each of these friends now tells 2 new people, after the third passing of the secret, 8 people will know. If this pattern of spreading the secret continues, how many people will know the secret after 10 such, quote, passings of the secret? Pause the video to give this a try. What's happening here is that for each person, the secret is doubling in the amount of people. So at first, with 0 passings of the secret, only your brother knows. And then after he passes it to you, after 1 passing, 2 people knows. After 2 passings, 4 people, 3, 8, and so on and so forth. So what's happening is that this is doubling each time, which means it's going to be y equals 2 to the power of x, x being the number of passings. So if it's 10 that we're trying to solve for, that's y equals 2 to the 10th power, which would be 1,024 people knowing your brother's secret after each person tells someone 10 times. A solution of a linear equation is an ordered pair x comma y that makes the equation true. The graph of a linear equation is the set of points x comma y in the coordinate planes that represents all the solutions. Sometimes the points are distinct and other times they are continuous, which is meaning they're connected. So sometimes they're individual points and sometimes it's connected to form a solid straight line. If they are distinct points, separate points, we say that that has a discrete domain where it only consists of certain values for x. If it's continuous, then we call that a continuous domain where it fits all values between a certain x and y, x value and another x value. So for example, this one would be the dotted graph and this one would be a solid line, filling everything in between the two endpoints, or potentially going on forever if it doesn't stop with infinity. So let's just take a look at a couple examples and see whether you think that it would have a discrete or continuous domain. For the first example, the linear function y equals 1595x represents the cost y in dollars of x tickets for a museum. Each customer can buy a maximum of 4 tickets. So our domain, which is our x values, is the number of tickets being bought. That would be discrete because you can only buy a whole number of tickets, 1, 2, 3, 4. For the second example, your friend runs at a pace of about 5 miles an hour. The linear function d equals 5h represents the total distance your friend runs after running for h hours. In this example, since you can stop running at any point in time, you don't have to run for a whole number of hours, we would say this is continuous because you can stop running at any time for a half an hour, a quarter of an hour, a tenth of an hour, or whatever fraction of an hour you choose. And then again, just to show you a little example of what the difference between the two might look like. Discrete would look like this one here on A, and continuous would look like the example over here at B.